Hello everyone and welcome back to Explore Engineering. In today's video, we are exploring the hardware components of the AmbuSens system and how they enable smart environmental monitoring. We will look at the IoT sensor node, sensing devices, communication modules, power supply, and cloud connectivity that work together to collect and transmit real-time data. So let's dive into and discover the technology behind AmbuSens. So the AmbuSens system, it is a healthcare monitoring system designed to continuously monitor a patient's physiological parameters using a wireless body area network, that is the WBAN. And it consists of three major hardware components, that is the sensors, then local processing unit, that is LDPU, and the communication module. Now first, let us look at the first hardwares, that is the sensors. So here, sensors are the primary data collection devices in the AmbuSens system, and here these sensors are non-invasive, they can monitor the patient's condition without penetrating into the body, and they continuously collect the physiological information and send it to the LDPU. Now here you have different types of sensors, that is the optical pulse sensor, then you have ECG sensor, EMG sensor, then next is the temperature sensor and the GSR sensor, and you will be having many more other sensors. So here we'll look at the sensors one by one. First is the optical pulse sensing probe. So here you can see that here it is used in the AmbuSens healthcare monitoring system, and it is one of the important sensors. Now this sensor, it is designed to measure the photophlethysmogram, that is the PPG signal. Okay, here PPG signal, which helps monitor blood flow and heart activity in a non-invasive manner. Now here you can see a patient is there. He is wearing a optical pulse sensor on the fingertip. Now the sensor, what it will do is it will emit the light onto the skin and measures the amount of light reflected back from the blood vessels. Here you can see the light, okay, which is indicated by red color. Now since the blood volume changes with every heartbeat, the reflected light, it will also change. Now these variations are used to generate the PPG signal, which provides the valuable information about the cardiovascular activity. This here you can see the working of the sensor, or the working principle of the sensor. First, what is done is the emitted light, it will penetrate the skin. Okay, here it will penetrate through the skin and it will interact with the blood flowing through the vessels. Now as the heart pumps the blood, then what happens is the blood volume changes and it will cause variation in the reflected light intensity. Okay, here you can see, okay, light is emitted, then it is reflected because of the blood flow. Now here there are some common locations where the sensor can be placed. So common locations are at the fingertip or the earlobe, then or other parts of the body locations with good blood circulation. Now such locations will provide accurate detection of the blood volume changes and also improve the quality of the PPG signal. Here you can see the main functions of the optical pulse sensing probe, that are, it will help in measuring the pulse rate, then monitoring the blood circulation and supporting health or the heart health assessment. Now these functions make it useful for continuous patient monitoring. Here you can see that it is shown here the transmission of the sensed data to the GSR. Okay, here this is the data which is collected from the device, that is the optical pulse sensing probe, and it is transmitted to the GSR module. So here GSR expansion module, and the module will receive the PPG data and it will forward it for the processing. Okay, so to the processing device in real time. Then the processed information can then be displayed on a monitor or the monitoring system, allowing the healthcare professionals to observe the patient's condition continuously and then take timely medical decisions whenever it is necessary. Next is the electrocardiogram, that is the ECG units and the sensor. So here the electrocardiogram, unit and sensor. It is also one of the most important sensors which is used in the AmbuSens healthcare monitoring system. And the ECG sensor, it is designed to measure the electrical activity of the heart. Okay, electrical activity of the heart, and it will continuously monitor the cardiac health, since the heart related information is critical for diagnosing and preventing cardiovascular problems. So the ECG monitoring plays a very important or vital role in the patient care. Now here you can see that a patient is shown connected to an ECG monitoring device here, okay, through several electrodes. These are the electrodes, these wires are there, no? These are the electrodes which are attached to the chest. Now these electrodes will detect the tiny electrical signals generated by the heart. Then like heart during the heartbeat. Now the monitor, what it will do, it will display an ECG waveform which represents the electrical activity of the heart in real time. And this waveform, it helps healthcare professionals to evaluate the heart performance and detect the abnormalities. And here you can see the components of the ECG kit. That is, you have ECG electrodes, then you have biophysical, that is 9-inch LEDs, and the biophysical 18-inch LEDs, alcohol swabs, and the wrist strap. So the electrodes, these are attached to the patient's body, while the LEDs carry the electrical signals from the electrodes. These are there, no? These are the electrodes, and these are the LEDs. And these are like here these will carry electrodes, these will carry the signals, okay, from the electrodes. Sorry, that is the LEDs will carry the signals from the electrodes to the ECG monitoring unit. Then the alcohol swabs are used to clean the skin before attaching electrodes, ensuring accurate signal collection. Now here you can see the working principle of the ECG sensor, that is the heart naturally generates the electrical pulses during the heartbeat. Now the ECG sensor, it will record these impulses and converts them into graphical waveform. Okay, these are the waveforms, and these reflect the heart's activity, and this waveform provides valuable information about the heart rhythm and overall cardiac function. Now here you can see some major functions of the electrocardiogram sensor, and these includes the detecting of the heart rhythm abnormalities, monitoring the cardiac health, then measuring the heart's response during the physical activity, and helping identify cardiovascular diseases. Now here you can see how the data flows from the ECG sensor through the LEDs to the LDPU, that is a local processing unit, and then to the processing device. So here you can see how the ECG technology enables continuous and reliable heart monitoring within the AmbuSens system. Next is the electromyogram EMG sensor. So here it is a biomedical sensor which is used in the AmbuSens system to measure the electrical activity which is produced by the muscles. Now the EMG, it plays an important role in monitoring the muscle movement, then evaluating the muscle health, and assisting the rehabilitation programs. Okay, so here you can see that a person is shown here. He's performing a muscle activity, and muscle activity exercise. He's doing some exercise here, while the EMG electrodes, these electrodes are attached to the arm. Now these electrodes will detect the small electrical signals generated when muscles contract and relax. And these electrodes, these will detect like these the signals, the detected signals are sent to the electromyogram, that is the EMG monitoring device, which records and displays the muscle activity. Now this demonstrates how the sensor can continuously monitor muscle function during the movement or any exercise. Now here you can see the purpose of the EMG sensor. Here it is used to analyze the muscle movement, study the biomechanics of the human body, and monitor the muscle contractions. Now by observing electrical signals from the muscles, the healthcare professionals, they can easily understand how muscles function during the different activities and identify the abnormalities in the movement patterns. Now here you can see the working of the EMG sensor, that is when a muscle contracts here or whenever there is an activity, then the electrical impulses are produced by the muscle fibers. Okay, here. Now after that, the EMG sensor, it will detect these signals through the surface of electrodes which are placed on the skin. Okay, these are the electrodes. Now these signals are then converted into an EMG waveform which can be analyzed to assess the muscle activity and performance. So here again you can see the functions of the EMG sensor, and these include evaluating the muscle health, assessing the nerve condition, detecting the muscle injuries, and measuring the muscle response during the rehabilitation. Okay, now such information, it will help the doctors and the therapist to determine the condition of the muscles and the nerves and monitor recovery progress. And here you can see that the EMG sensor, it is particularly useful for patients recovering from injuries, surgeries, or neurological disorders. Okay, here. So here you can see how the EMG data flows from the sensor through the interface and the LDPU, that is a local data processing unit, to the monitoring system. So this image shows that how the EMG sensor supports accurate muscle assessment and continuous monitoring, patient monitoring within the AmbuSens healthcare system. Next is the temperature sensor. So here again, temperature sensor, it is one of the most important sensor which it will continuously monitor a patient's body temperature. And body temperature, it is very important and vital physiological parameter which provides the important information about a patient's health condition. Now changes in the body temperature can indicate infections, then fever, inflammation, or other medical problems, making continuous monitoring essential. Now here you can see that a patient is shown wearing a small temperature sensor which is attached to the arm here. Now the sensor continuously measures the body temperature and it will wirelessly transmit. Here you can see the symbol wirelessly it will transmit the collected data. Now you will be having a nearby monitoring screen which will display the patient's temperature reading and trends in real time. So here we understand that the healthcare providers can remotely observe a patient's condition without frequent manual measurements. These are some of the functions of the temperature sensor. That is, the sensor continuously measures the body temperature, helping healthcare professionals track changes over time. And also it can detect fever or abnormal temperature fluctuations and assist in identifying the infections and illness at early stage. And the continuous temperature monitoring is especially useful for hospitalized patients or like elderly individuals and the people with chronic health conditions. Now there are some advantages of the temperature sensor. That is, it is small and also it is light in weight and it is comfortable to wear, making it suitable for long-term use. And the sensor can be easily placed on the patient's body and provides uninterrupted monitoring without causing discomfort. And these features make it ideal for continuous healthcare applications. Now here the importance of the temperature monitoring system, you can see it by a alert system here. Okay, here. That is, its sudden increase in the temperature, it will trigger a warning notification and it will allow the healthcare professionals to respond quickly to potential medical emergencies. So such alerts can help prevent complications by enabling timely medical intervention. Now here you can see the working or the flow of the data in the AmbuSens system, where the temperature readings are transmitted from the sensor to the LDPU, then forwarded to a processing device, and finally to the cloud-based monitoring system. So this allows the doctors and the healthcare staff to assess real-time temperature data and make informed decisions for improved patient care and safety. Then you have the galvanic skin response, that is the GSR sensor. So GSR sensor, it measures the changes in the electrical conductivity of the skin. Okay, electrical conductivity of the skin, which will vary according to a person's physical and emotional state. Now these changes occur due to factors such as stress, emotional states, sweating, physiological reactions. And Here you can see that a patient is there. He is wearing finger electrodes connected to a GSR monitoring device. Now these sensors will continuously measure the skin conductance and displays the collected data on a monitoring device or the monitoring screen. Now here this shows how the GSR sensor can monitor changes in the body's physiological condition in real time. Here you can see the working principle of the GSR sensor. Human conductivity changes because of variations in the sweat gland activity. So, when a person experiences stress, excitement, fear, anxiety, or other emotional states, the sweat glands become more active, causing changes in the skin conductivity. Okay, here. Now, what happens is this GSR sensor, it will detect the small electrical changes through the electrodes attached to the skin and converts them into measurable signals. So the image here, you can see this image. Okay, here it highlights this whole image. It highlights 4 major factors which influence the skin conductivity. Major are stress, emotional states, sweating, and physiological reactions. These are some of the functions of the GSR. That is, it will measure the skin resistance, detects the emotional stress, monitors the physiological responses, and assist in the health assessment. Okay, and these functions helped the healthcare professionals to understand both the physical and the physiological conditions of the patient. Now, here you can see the importance. Okay, here you can see the importance of the GSR sensor in evaluating the patient's well-being. Now, by monitoring the skin conductance, the healthcare providers can gain insights into the stress levels, emotional responses, and the nervous system activity. So this information, it is particularly useful in mental health monitoring, stress management, rehabilitation, and the patient assessment. So you can tell whether a person is in stress or he is happy, like that. Now here you can see the flow of the data. That is, the data is collected first by the sensor and it is transmitted to the LDPU, then forwarded to the processing device and to the cloud-based monitoring platform. So this enables continuous remote monitoring and helps doctors to make informed decisions regarding the patient care and overall health management. Then the second component is the local data processing unit, that is the LDPU. So LDPU, it serves as the central processing unit, that is central processing node. Okay, central processing node of the AmbuSens healthcare monitoring system. And this LDPU, it acts as an intermediate device between the body, okay, between the body and body sensors and the cloud or the monitoring platform, and it collects the physiological information from various sensors which are attached to the patient and manages the flow of data within the system. Like here you have some sensors on the arm, on the chest, then at the finger. Okay, so here again you can see the patient is wearing multiple healthcare sensors connected through a wireless body area network, and these sensors include the ECG sensor, EMG sensor, then temperature sensor, you have GSR sensor, SpO2 sensor. Okay, and these sensors continuously monitor different physiological parameters of the patient and send the collected information to the LDPU. So the LDPU, it acts as a central hub that gathers information from all connected sensor nodes. Here you can see the LDPU. This is a definition of the LDPU. It is a compact processing board with limited computational capability, which collect the data from all the sensor nodes attached to the patient's body. Now, despite its small size, the LDPU, it is capable of receiving data from multiple sensors simultaneously and managing communication between the patient monitoring system and the external networks. So here you have some major functions of the LDPU, which include the data collection, temporary storage, then data transmission, and the network topology management. So these functions they play a very important role in handling the sensor data before it is forwarded for the processing. And here you can see the network topology, which demonstrates a star topology here, where all the sensor nodes, okay, all the sensor nodes, these will communicate directly with the LDPU. And in this arrangement, the LDPU acts as the central node, while the sensors, these sensors will serve as peripheral devices connected to it. Again, here at the bottom, you can see that here you have a cartoon LDPU. Okay, now the LDPU, like, it summarizes the role of the LDPU in the AmbuSens system. The LDPU will collect the data from various sensors, processes it locally, stores it temporarily and required, like whenever it is required, and it will transmit it to the next processing stage or the cloud platform. So the LDPU, it is the core component which is responsible for coordinating the data collection and communication in the AmbuSens healthcare monitoring system. Now, next is the data collection. So here the data collection function of the LDPU is being shown in the AmbuSens healthcare monitoring system. The LDPU, it acts as a central hub that gathers the physiological data from multiple sensors which are attached to the patient's body. And again, you can see here that a patient is there. Here he is wearing different medical sensors, and these will monitor continuously monitor the various health parameters. So here the ECG sensor, it records the electrical activity of the heart. Then you have the EMG sensor, which will measure the muscle activity. Temperature sensor monitors the body temperature. Then you have GSR sensor, which measures changes in skin conductivity. And finally, optical pulse sensor, which monitors the pulse related information. So each sensor transmits its collected data to the LDPU through wireless communication. Now here at the center of the image, you can see the LDPU is shown receiving the data from all the sensors. Here this demonstrates, like, again, one more thing is you can see the arrow marks here. It means that the data is being collected by the sensors and it is transmitted to the LDPU. So this demonstrates how the LDPU serves as the main collection point for physiological data within the AmbuSens system. Here are some of the sensors connected to the LDPU. Okay, these sensors, fine. And the LDPU, it will combine the incoming data and it will prepare it for the further processing. So again, here you can see that the LDPU, it acts as a central hub. That is, after collecting the data from all the sensors, the information, it can be forwarded to the monitoring systems or cloud platforms for storage, analysis, and remote healthcare monitoring. So this will enable the continuous observation of the patient's health condition and it will support timely medical decision making. Now you have the simultaneous processing. So here the simultaneous processing, like here the LDPU, it will act as a central processing device that will receive the data, manages and then forwards all the physiological data collected from the various body sensors. Now here you can see the simultaneous, okay, this part, upper part, this is the simultaneous processing. A patient is shown here, is wearing multiple sensors, which includes all these sensors here. Now these sensors continuously collect the physiological information from the patient's body and then it will transmit it to the LDPU. Now here you can see the arrow marks which indicate that the data from the sensors, it will reach the LDPU at the same time. So the LDPU, it is designed to receive multiple data streams simultaneously and process them without interruption. So this capability, it enables the real-time monitoring of the several health parameters together, and it will allow the healthcare professionals to obtain a complete picture of the patient's condition. So here it highlights some of the benefits also, such as the fast data handling, real-time monitoring, then you have accurate analysis and better patient care. Now here, this lower section, this section of the image, it shows the temporary storage function of the LDPU. That is, after receiving the data from the sensors, the LDPU can temporarily store the collected information and like, it can store it in its internal memory before the transmission. And this feature It is useful when the network connectivity is unavailable or it is unstable. So at that time what happens is the stored data, it remains safely preserved inside the LDPU here, and until when the communication is restored. So once the connection is restored, or when it is become available, the LDPU, it will forward the stored information to the cloud server, okay, here, or the next processing stage. So here you can see some advantages of the temporary storage, which includes the prevention of data loss, that is during the network interruptions. Then you have reliable data delivery and improved system efficiency. So by combining simultaneous processing and temporary storage, the LDPU ensures continuous and dependable health monitoring. Here the functions allows the, or these advantages allows the AmbuSens system to collect, manage and transmit patient information efficiently, ensuring that critical health data is available for analysis and medical decision making whenever needed. Then next is the data transmission. So data transmission, like here, these functions will enable the efficient communication between the body sensors, the LDPU and the cloud-based healthcare devices. Now here again you can see that this part, okay, this part, it mainly focuses on the data transmission, upper part. Here a patient is shown, again he is wearing multiple sensors, multiple physiological sensors. These are the types of the sensors he is wearing, and these sensors will continuously collect the health related information, and these will send it to the LDPU. Now the LDPU, it will act as an intermediate processing unit that will gather the incoming data, and it will forward it wirelessly to the cloud servers. Now here you can see the three main purposes of transmitting the data to the cloud. First is the long-term storage, then you have advanced analytics, then third is the medical record maintenance. This long-term storage, it will allow the patient information to be preserved for future reference, while the advanced analytics, it will help the healthcare professionals analyze trends and detect abnormalities, and the medical record maintenance ensures that patient health information is securely organized and readily accessible whenever it is needed. Here you can see the network topology. This part, it shows the network topology which is used in the AmbuSens system. Now the communication between the sensors and the LDPU, it follows a single hop star topology. Okay, here single hop star topology. Now in this arrangement, the LDPU is serving as the central hub, while these all sensors are connected directly to the LDPU. Now the arrow marks, okay, here you can see the arrow marks which show that each sensor communicates independently with the LDPU. There are no direct communication links between the individual sensors, and this structure, it simplifies network management and it reduces the communication complexity. So here again you have some advantages also for the network topology, as since all the data passes through the central LDPU, the communication becomes more organized and reliable, and direct communication between the sensors and the LDPU helps reduce delays and power consumption, which is very important for wearable healthcare devices. Now here you can see a doctor, he is nothing but a health care professional who can access the transmitted information for monitoring and decision making. So the LDPU efficiently collects the sensor data, transmit it to the cloud servers, and it will manage communication through a star topology to support continuous and reliable patient monitoring. Next, you have advantages of the LDPU. So here, like LDPU, it serves as a central processing unit or the device that will receive, manage and transmit the data collected from multiple physiological sensor, and these sensors, these are attached to the patient. So here you can see that how LDPU contributes to the efficient and reliable healthcare monitoring. Now here a patient is shown, he's wearing various types of sensors, and these sensors will continuously collect the physiological information, and it has been sent to the LDPU. Now this LDPU, again, it acts like a central hub that gathers the data from the collected sensors, sensor nodes before forwarding it to the cloud or the monitoring systems. Now, the first advantage of this LDPU is low power consumption. That is, it is designed to operate using minimal energy, making it suitable for wearable healthcare applications. And lower power consumption helps to increase the battery life and supports continuous monitoring for longer durations. Then another important advantage is the fast data aggregation, where the LDPU quickly receives the data from multiple sensors and combine it efficiently. And this will allow the patient information to be collected and organized without delays, ensuring smooth system operation. Then you have efficient management of sensor data, where the LDPU organizes, processes, and manages incoming information from different sensors. And this will help the healthcare system maintain accurate records and simplify the decision making. Then next you have reduced communication complexity, where this LDPU is acting as a central node in the star topology network, and instead of sensors communicating with each other, all communication takes place through the LDPU. And this reduces the number of communication links and it simplifies the network management. And finally, here you have the last advantage, that is the real-time monitoring support. That is, by continuously collecting and forwarding data, the LDPU enables the healthcare professionals to monitor patients' condition in real time. And this will allow faster responses to medical situations and it will improve the patient care. Then now comes the third component, that is the communication module. Okay, so here in like this communication module, it will enable the wireless communication between the body sensors and the local data processing unit, allowing the continuous transfer of the physiological data without the need for wired connection. Okay, now here again, patient is wearing the various types of sensors, and each sensor node, it is equipped with a Bluetooth. Okay, here you can see it is having Bluetooth. It is equipped with Bluetooth module based on the IEEE 802.15.1 standard. And this Bluetooth enabled sensors, these will collect the physiological information and it will transmit it wirelessly to the LDPU for further processing. Then here you can see that the LDPU, it is receiving the sensor data through the Bluetooth. Okay, here Bluetooth is there. Now the wireless connection, it will eliminate the need for physical cables and it will allow patients to move comfortably while being monitored. So the communication process forms a WBAN, that is a wireless body area network, which will connect all sensor data nodes to the LDPU. Now here you can see highlights of the image highlights, that is the features of the Bluetooth. Okay, here you can see the features of the Bluetooth, which includes the short range wireless communication, low power consumption, then reliable connectivity and easy integration with medical devices. So these characteristics will make the Bluetooth suitable for wearable healthcare applications. And here you can see the communication range of the Bluetooth. Okay, the maximum communication distance is approximately 10 meters under the line of sight conditions. So this range is sufficient for transmitting the data between the sensors and the LDPU in a healthcare environment. These are some of the major functions of the communication module. It will transfer the physiological data from the sensors. Then it supports real-time monitoring and maintains wireless connectivity within the WBAN. So overall, you can say that communication module ensures efficient, reliable and low power wireless data transmission, enabling continuous health monitoring and improving the patient care within the AmbuSens system. Here this is the LDPU to cloud communication. After collecting and processing the physiological data from the various body sensors, the LDPU will transmit the information to the cloud servers using what? Using the 3G, 4G, okay, 3G and 4G communication networks. Now again, you have patient, he's wearing different types of sensors. So these sensors will collect data. It is being transmitted to the LDPU. The LDPU will act as a central processing unit, and it organizes and prepares the information for transmission. So the LDPU is sending the data to the cloud server. That is the secure cloud server. Here you can see one symbol here. So it is a secure cloud server. So how it will be sending? It will be using the 3G and the 4G connectivities and sending the data. So the cloud servers, what they will do is they will store and manage the received information. Now here we can see some of the function of the cloud communication, that is remote patient monitoring, then long-term health record storage, and you have real-time access by healthcare professionals, and finally advanced cloud-based data analytics. So here overall you can say that the cloud connectivity will enable the continuous, secure and efficient healthcare monitoring from anywhere, from anywhere. Okay. And this is the overall working of the AmbuSens hardware. That is, the sensors will collect the monitor the patient health parameters. Then the sensor data is transmitted to the LDPU through the Bluetooth. Then the LDPU will collect and process the incoming data. In the fourth stage, processed information is sent to the cloud servers through the 3G or 4G networks. And finally, the doctors and the healthcare staff access the information remotely for monitoring and decision making. So that's a quick overview of the hardware components which are used in AmbuSens system. I hope this video helped you understand how these devices work together for efficient real-time monitoring and data collection. If you found this video useful, please like, share and subscribe to my channel for more videos on healthcare IoT and smart technologies. Thanks for watching and see you in the next video. Thank you.